everyone, this is Kalpana here. In this video, we are going to solve the given differential equation. So let's get going. Problem. Solve d cube y by dx cube plus 6 into d square y by dx square plus 11 into dy by dx plus 6y equals to 0. So we are given a linear homogeneous equation, right? If you use the differential operator d, you can replace d by dx by differential operator d, right? Then this equation becomes given differential equation d cube y by dx cube plus 6 into d square y by dx square plus 11 into dy by dx plus 6y equals to 0. Okay, now use this, then you can write the above equation as d cube y plus 6d square y plus 11 dy equals to plus 6y equals to 0. Now take y common from all the terms of LHS, then you get d cube plus 6d square plus 11d plus 6 into y equals to 0, right? Which is in operator form. That is f of d into y equals to 0, right? Where f of d equals to by comparing these two, we'll get f of d, right? Where f of d equals to d cube plus 6d square plus 11d plus 6. Fine, let it. Now coming to the given equation. So we wrote the given equation in differential operator form, right? Now, what is the degree of the given equation? Order and degree of this equation. We'll see what is order and degree of the given equation. Firstly, we'll find the order. So find the highest derivative in this equation. This is dy by dx, d square y by dx square, no. And this is d cube y by dx square. So this is the highest derivative in this equation, right? So our order will be 3. Now coming to the degree. So the power of highest derivative of the equation is your degree. So here you don't have any square, cube or anything. You just have 1, right? So our degree is 1. That is the order and degree of the given equation is 3 and 1. Fine. Now we need to find the general solution to the given equation. So how we can find? Using the auxiliary equation. The auxiliary equation of equation f of d into y equals to 0 is f of m equals to 0. So how we'll get f of m? Simply by replacing m in f of d, you'll get f of m, where f of m equals to m cube plus 6m square plus 11m plus 6, right? Fine. Now, our auxiliary equation is m cube plus 6m square plus 11m plus 6 equals to 0. Now consider this polynomial. We'll find factors of this polynomial. Okay, so how we can find that? we'll use synthetic division method. Okay, here we are going to use synthetic division method to find roots or factors. Okay. So, consider the polynomial m cubed plus 6m squared plus 11m plus 6. Now, we have to check whether the equation satisfies for m equals to 1 or minus 1 or 2 or minus 2. We'll see. Okay. Firstly, let's check for m equals to 1. What we'll get? If you put m equals to 1, you'll get 1 cube plus 6 into 1 square plus 11 into 1 plus 6, which is equals to 1 plus 6 plus 11 plus 6 not equals to 0, right? So, it does not satisfy for m equals to 1. Now, go for m equals to minus 1. Then, you'll get minus 1 cube is minus 1 plus 6 into minus 1 square is 1 plus into minus is minus 11 into 1 11 plus 6 is equals to minus 1 plus 6 1 6 minus 11 plus 6, which is equals to minus 1 minus 11 is minus 12, 6 plus 6 is plus 12, which is equals to 0. So m equals to minus 1 satisfies this polynomial, right? So here m equals to minus 1 will be one root. From this we'll get a factor m plus 1. Right, from this we can write m plus 1 equals to 0, right? So here m plus 1 is one factor. Let's see. Using synthetic division now. How we can use the synthetic division? Take the quotients of m. Firstly 1 cube, square, m and constant or m power 0. Right? Put 0. Now for m equals to minus 1, 1 plus 0 will add 1. Minus 1 into 1 is minus 1. 6 minus 1 is 5. Minus 1 into 5 is minus 5. 11 minus 5 will get 6. Minus 1 into 6 is minus 6. Again 6 minus 6 is 0. The remainder, right? Again, you can write this into a polynomial square 1 constant, right? M square 5m plus 6. You will get m square plus 5m plus 6. Just observe the places. Okay? Constant, m and square. So, here, either you can use factorization to find factors or you can check like this. Okay, it's up to you. Now, I'll just find using factorization method. I'll find factors using factorization method. Plus 3m plus 2m plus 6 is equals to m times m plus 3. We'll just take m common from the first two terms, then you'll get m times m plus 3 plus take 2 common from the next two terms, you'll get 2 times m plus 3. Now, take m plus 3 common from these two terms, then you'll get m plus 3 times m plus 2. These are the other factors for this equation or this polynomial, I can say, right? So you can write this polynomial as product of 3 factors. M plus 1 into m plus 2 into m plus 3. I just wrote in order. Okay, from this we'll get m equals to, simply consider m plus 1 equals to 0, m plus 2 equals to 0, m plus 3 equals to 0. Then from this we'll get m equals to minus 1, m equals to minus 2, and m equals to minus 3, right? Which are the roots from these factors. We'll get m equals to minus 1, minus 2, minus 3. So here the roots are roots of auxiliary equation, that is f of m equals to 0, or this equation I can say. So now you got roots are real and distinct. You don't have any repeated root, right? So we can say that the roots are real and distinct. It is a real number, right? Fine. When the roots are real and distinct, our formula will be y equals to c1 e power m1x plus some constant into e power root into x plus some constant into e power root into x plus so on plus cn e power mn x. So how many roots we have? 1, 2, 3. So we need the first 3 terms. Okay. Therefore the general solution is y equals to c1 e power first root minus 1 into x, or better write minus 1 into x, plus c2 into e power minus 2 into x plus c3 into e power minus 3 into x. We get c1 e power minus x plus c2 e power minus 2 into x minus 2x plus c3 e power minus 3x, which is the required solution to the given equation. So we have seen a problem from differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.